This is still section 2.1 on solving simple equations, and we're going to be doing example number 2, which has to do with deflection of a beam. What determines how much a beam will flex and bend when it's used in a house or a bridge application? Well, it's the moment of inertia that will determine that. Moment of inertia is a member's, like a wood member or steel member's, ability to resist any kind of twisting or bending, that kind of thing. And deflection is simply the amount that it goes down when you're walking on it, when it has a load on it. So we're going to be given some information, and we're going to be putting this formula to use. And we're going to do this problem a couple of different ways, and then you'll be able to better judge which way you like best. So let's start with the formula. D is equal to PL cubed over 48EI. And so in this sample, we're going to go ahead and substitute in the values, and then we'll solve for, in this case, I. And then we're going to do it a little bit differently, and then you can decide what you like. So in place of D, I have a 1. And in place of P, I've got 3250 times the length, which is 156 cubed. And this is over 48 times 1,950,000. 1,950,000. I'm going to put that in parentheses so it's easy to see. Times I. Okay. Alrighty. Well, whenever we're solving for a variable and the darn variable is down in the denominator, that's not a good location. So what we're going to do is we're going to make this problem so easy. We are going to pop that guy right out of there. And the way we're going to pop it out is we're going to get rid of it in the denominator location. And the way we get rid of it in the denominator location is we're going to multiply this side of the equation by I. And you can think of it as I over 1. And you can see those i's are going to drop out. They're going to reduce down. And what I do to one side of the equation, I do to the other. And wow, I'm really liking this because of this really simple number over here. So let me clean this up for a second. Show that I'm reducing. I times 1 is just I. And I have all this stuff on the right. 3250 times 156 cubed over 48 times 1,950,000. 1,950,000. Well, jeepers. I have this guy all by himself. All the numbers are on the right. And now I'm going to bring my calculator in and let it do all the rest of the work. So let me turn it on and clear it. 3250 times 156 to the, notice I can use my caret key here, to the third. There's my numerator. Don't worry about how it looks. Divided by parentheses. This is, oops, only 1, Kathy. This is critical. Parentheses. 48 times 1950 and 3 more zeros. Close that, and I get 131.82. I'm going to go back just to be on the safe side. Make sure I put that one incorrectly. Let's see. 1950 and 000. Okay, good enough. I'm happy with that. Let's get to the end here. Okay. Whatever. I kind of messed something up there. All right, so I have this moment of inertia, and the directions that I was supposed to do were to round this off to the nearest whole number, so I'm going to do that. So that's 132. 132. And my units of measure on moment of inertia is inches to the 4th. Okay, so let's redo this problem a little bit differently and compare the two in terms of the amount of effort that's required. The starting point is the same. Copy down the formula. But this time, before I plug in any values, I am going to isolate the variable. And I'm going to isolate the variable very similarly to the way I did it over here. I don't like this guy being down here. So I'm going to multiply both sides by I. So I'm going to have d times I is equal to PL cubed 48EI times I. And I can make that look like a fraction over 1. And these guys reduce out. And I'm left with di is equal to PL cubed over 48E. Okay, so far so good. I just got to get rid of this fellow right here. Got to get rid of him. And I'm going to do that by breaking that link, dividing. I'm going to divide both sides by d. And if I divide this side by d, I get I. And if I divide this side by d, what happens is he ends up down here in the denominator. So, well, how'd that happen? Well, if you think about it, I'm going to kind of jot this down over here. PL cubed over 48E. If I divide this side by d, isn't that the same thing as multiplying it by 1 over d? PL cubed over 48E. And then you multiply straight across. PL cubed times that is that. And this guy times this guy is that guy. Okay, so I haven't really solved the problem yet. All I've done was isolate the I. And now I'm ready to plug in the values. And in place of the weight, which is P, I get 3250 times my length, which is 156 cubed. I got a 48 times 1,950,000 times D. What's D? What did we say D was? Times 1. Okay. And I'm ready to put all that in my calculator. 3250 times 156 to the third. It's kind of shiny. Sorry, can't see it there. To the third. Move this over. And put an equal sign in there. Divided by parentheses 48 times 1,950,000 times 1. Well, I don't need that 1. 131.82. I'm real happy about this because, thank goodness, it came out to be the same answer. 131.82. Follow the rounding directions to the nearest whole number, 132, and my units are still inches to the fourth. So in this particular case, this one was a lot easier than this one. It's not always going to be that way. So it's really helpful if you learn how to choose. Intelligently choose. Okay, so that was example 2.